Now, in this lecture, we'll find out the area of the green shape using two different methods. In the drawing, we have a circle. Inside this circle, we have triangle ABC. Actually, triangle ABC is blocked by this circle. We also know that side AB of this triangle ABC equals to 13 units in its length, side BC equals to 14 units, and side AC equals to 15 units. Again, our mission is to find out the area of this green shape. Okay? So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. Actually, rule number 4. According to rule number 4, the area of triangle ABC is equals to the square root of S times A times S minus the square root of S times S minus A times S minus B times S minus C. So in the drawing we have triangle ABC, and you know that the length of side AB is equal to a unit, side BC equals to B units in its length, and side AC equals to 3 units in its length. And the semi-perimeter of this triangle ABC equals to the perimeter that is A plus B plus C, the sum of its sides, over 2. So A plus B plus C over 2 is the semi-perimeter of this triangle ABC. That is to say, S, the semi-perimeter, equals to A plus B plus C over 2. Okay, so according to this rule number 4, the area of this triangle ABC, that could be any triangle. Here the square brackets is the sign for the area. It means the area of triangle ABC is equals to the square root of S. S is the semi-perimeter, that equals to A plus B plus C over 2 times S minus A times S minus B times S minus B. I repeat again that A, B, and C are the side lengths of this triangle ABC. So actually we can implement rule number 4 in our drawing. Why? Because rule number 4 is true in any triangle, and especially in our triangle ABC. So first of all, we will define the length of side AB as A. And we know that the length of side AB is 13 units, so A equals to 13 units. We define the length of side BC as B, so we know that BC equals to 14, so B equals to 14. And finally, we define the length of side AC as C. And we know that side AC equals to 15 units, so C equals to 15 units in its length. I'm writing down here that A equals to 13, B equals to 14, and C equals to 15 units. In the next step, we'll find out the semi-perimeter of this triangle ABC. So the semi-perimeter S, it is equals to A plus B plus C over 2. Repeat again, the semi-perimeter S of our triangle ABC equals to A plus B plus C over 2. A is 13 plus B, that is 14, plus C, that is 15 over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So S, the semi-perimeter of our triangle ABC, is equals to 21 units. Again, according to rule number 4, the area of our triangle ABC is equals to the square root of S times S minus A times S minus B times S minus C. That is to say, the area of our triangle ABC will be equal to the square root of S. S is 21 times S minus A. S minus A is 21 minus 13 times S minus B. S minus B is 21 minus 14. And finally, S minus C is 21 minus 15. All under the root. Okay. So, the area of our triangle ABC is equal to the square root of 21 times 21 minus 14 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. So the area of our triangle ABC, according to the new rule number 4, it is equal to the square root of 21. We substitute 21 by 3 times 7. It is 21 times 8. We substitute 8 by 2 times 2 times 2. Times 7 times 6. We substitute 6 by 3 times 2. In the next step, we will arrange the numbers inside the root in a different order. And finally, we will get that the area of our triangle ABC, according to the new rule number 4, is equal to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. Okay, we just arrange the numbers inside the root in a different way. We got this expression. The area, the square root of 3 times 3 is 3, and the square root of 7 times 7 is 7, times the square root of 2 times 2 is 2, and again we have the square root of 2 times 2, that is 2. Here 3 times 7 is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. Finally, we actually found out that the area of our triangle ABC is equal to 84 square units. From the drawing, it is very clear that the area of the green shape, it is equal to the area of the circle minus the area of triangle ABC. We just right now found out that the area of triangle ABC equals to 84 square units. So in the next step, we'll find out the area of the circle. This circle blocks triangle ABC. So I present to you a new rule number 6 that will help us to find out the area of this circle. Okay. Actually, rule number 6 is about the radius of a circle that blocks triangle ABC that could be any triangle. Here in the drawing we have a circle. This circle blocks triangle ABC. We know that the length of side AB of triangle ABC is equal to A unit, side BC equals to B units in its length, and finally side AC equals to C units in its length. And according to our definition, the radius of this circle is R. So according to this rule number 6, the radius of this circle that blocks triangle ABC will be equal to A times B times C, that is the multiplication of the side lengths of the triangle by each other, over 4 times the area of this triangle, triangle ABC. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing, we have a circle that blocks triangle ABC. So according to rule number 6, we will define the radius of this circle as R. Point O is the center of the circle, point B is the point of the circle itself. Therefore, OB is the radius of this circle that we will define as R. So the radius R, according to rule number 6, will be equal to A times B times C over 4 times the area of triangle ABC. Again, this equation is the implementation of rule number 6 in our drawing. A is 13, B is 14, and C is 15 over 4 times the area of triangle ABC. We just right now found out that the area of triangle ABC equals to 84 square units. So the area of triangle ABC is 84, 4 times 84. So we will divide both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. So in the numerator we left only with 13 times 15. We also have to divide the denominator by 14. So in the denominator we have 4 times 84 over 14 is 6. So we left only with 4 times 6 in the denominator. Okay. So here we will divide both the numerator and the denominator of this expression by 3. In the numerator we have 13. So it will be 13 times 15 over 3 is 5. So in total in the numerator we left only with 13 times 5 over 4 times 6 over 3 is 2. So in the denominator we left only with 4 times 2. 4 times 2 is 8, and 13 times 5 is 65. In conclusion, we found out that the radius of this circle R that blocks the triangle ABC, the radius R equals to 65 over 8 units. Repeat again, the radius R here is equal to 65 over 8 units. Repeat again that the area of the green shape is equals to the area of the circle minus the area of triangle ABC. The area of the green shape is equals to the area of the circle minus the area of triangle ABC. The area of the circle is equals to pi r squared minus the area of triangle ABC. We have already found out that the area of our triangle ABC it is equals to 84 square units. This is minus 84. What is the value of pi r squared? It is pi times r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. Minus 84, that is the area of triangle ABC. This expression in total is equals to 207.39 207.94 square units, that is actually the area of the circle, minus 84, that is the area of triangle ABC. 207.394 minus 84 is equals to 123.394 square units. And that is the answer to the question. I'll repeat again. According to the first method, the area of this green shape, it is equal to 123.394 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will do a construction, that is to say, from point A, we will draw perpendicular on BC. From point A, we will draw perpendicular on side BC, or triangle ABC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A inside BC is M. We will define the length of side AM or the perpendicular AM as H. We will define the length of side BM as X. What is the length of line segment CM? From the domain, it is very easy to see that CM equals to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. In the next step, I will copy the right triangle, triangle A and B in a new page, and we will implement on this right triangle, triangle A and B, the Pythagoras theorem. Here, by PT is abbreviation for Pythagoras theorem. So this is the right triangle, triangle A and B that I copied from the original drawing. Side AM equals to H according to our definition. BM also equals to X according to our definition. And the hypotenuse AB equals to 13 units according to what is given us the question. So here, according to the Pythagoras theorem, we get that AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169. And it is equals to AM squared. AM is h, therefore M squared is h squared plus BM squared. BM is x, therefore BM squared is x squared. So in total, we found out that according to equation number 1, 169 equals to h squared plus x squared. Here we subtract x squared from this equation, equation number 1. And finally, we found out that according to equation number 1, h squared equals to 169 minus x squared. In the next step, I will copy the right triangle, triangle AMC in a new page, and we will implement on this right triangle, triangle AMC, the Pythagoras theorem. So actually, this is the right triangle, triangle AMC that they call it from the original drawing. The hypotenuse AC equals to 15 units, and its length according to what is given as the question. AM equals to h according to our definition, and we've already found out that sine MC equals to 14 minus x. By PT is the evaluation from Pythagoras theorem, so according to the Pythagoras theorem, in this right triangle, triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225. And it is equals to AM squared. AM is h, therefore AM squared is h squared plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. Here we subtract 14 minus x squared from this equation, equation number 2. And we get that according to equation number 2, h squared equals to 225 minus 14 minus x squared. This is according to equation number 2. While according to equation number 1, we have already found out that h squared equals to 169 minus x squared. So we have two different equations for the value of h squared. Therefore, in the next step, we will create equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 is equals to 169 minus x squared, and it must be equal to h squared according to equation number 2, that is equal to 225 minus 14 minus x squared. So according to this equation, equation number 3, we actually found out that 100, 169 minus x squared equals to 225 minus 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So 169 minus x squared equals to 225. We'll open the brackets here. We have minus before the bracket, so here we get minus 196 minus x squared, minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. In this side of the equation, we left only with 169 after we cancelled minus x squared. In the other side of the equation, we have 225 minus 196, this is 29, plus 28x. The conclusion found out that according to equation number 3, 169 equals to 29 plus 28x. Here we'll subtract 29 from this equation number 3, and we get that according to equation number 3, 169 minus 29 is 140. That is equal to 28x. Here we divide this equation number 3 by 28, and finally we get that x equals to 140 over 28 is 5, so x equals to 5. According to equation number 1, we found out that h squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared. But x is 5, therefore x squared is 25. So h squared equals to 169 minus x squared, that is minus 25. 169 minus 25 is 144. So finally we found out actually that according to equation number 1, h squared equals to 144. Here we take a root out of this equation number 1, and finally we get that h equals to the square root of 144, that is 12. H equals to 12 units. Here AM, that is equal to h, equals to 12 units, and x equals to 5. In the next step, we will define the center of this circle as O. And we'll join points O and A together by straight line. Point O is the center of the circle. Point A is the point of the circle itself, therefore OA is the radius of the circle. We define the radius of this circle as R, so OA equals to R. In the next step, we will extend the radius OA by a straight line until it touches the circle. And we define the touching point of the extended radius AO and the circle is point P. OA as a radius, it is absolutely a straight line. We extended the straight line OA by a straight line and the result is AP. When you extend a straight line by a straight line, the result must be a straight line. So AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes from point O, that is the center of the circle. And we know that any chord that passes from the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of this circle. So I write it down. AP is the diameter of the circle. Here, point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle, that is equal to R. What is the length of AP? The length of the diameter AP, it is equal to R plus R, that is to R. So AP equals to 2R, and the diameter is always twice as long as the radius. The radius is R, therefore the diameter is 2R. You can say it from the drawing that the radius is R, therefore the diameter in total is equal to AO, that is R, plus OP, that is R. So in total, the length of the diameter AP equals to 2R. Okay. In the next step, we will join points P and C together by a straight line. By joining points P and C, we actually created here peripheral angle ACP. This is peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing we have peripheral angle ACB. This peripheral angle ACB rests on AB, that is the diameter of the circle. AB is the diameter of the circle. And therefore, according to this rule number 7, this peripheral angle ACB equals to 90 degrees. So we can actually implement rule number 7 in our drawing. Why? Because in our drawing, we have peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, peripheral angle ACP must be equal to 90 degrees. In the next step, I will present to you a new rule number 8, and we will implement rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. So in the drawing we have two peripheral angles. Those are the two peripheral angles. This peripheral angle ADB rests on chord AB. The other peripheral angle ACB, rests on the same chord, chord AB. So, because of the fact that those two peripheral angles, they both rest on the same chord, chord AB, therefore they must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ECB that rests on the same chord, chord AB, must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing, we have peripheral angle APC. This is peripheral angle APC. This peripheral angle APC rests on chord AC. We have another peripheral angle ABC. This peripheral angle ABC rests on the same chord, chord AC. So actually, those two peripheral angles, they both rest on the same chord, chord AC. Therefore, they must be equal to each other. That is to say, if the size of peripheral angle ABC is equal to theta, then the size of the other peripheral angle APC that rests on the same chord, chord AC, must be also equal to theta. In the next step, we'll focus on the right triangle, triangle APC. On the right triangle, triangle APC, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle, triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle, triangle APC, this right triangle APC is similar to the right triangle, triangle ABM. We prove that those two right triangles are similar to each other. So I write it down. We prove that the right triangle, triangle AMB is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So this is angle ABM, and it is equal to this angle. This angle ABM belongs to triangle AMB, and it is equal to this angle, that is angle APC in triangle ACP. I'll repeat again. Angle ABM in triangle AMB equals to angle APC in triangle ACB. They are both equal to theta, therefore they are equal to each other. In addition, we have those two angles, they are both equal to 90 degrees, therefore they are equal to each other. This is angle AMB in triangle ABM, and it is equals to this angle. This is actually angle ACP in triangle APC. Repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB. In triangle ABM, it is equals to this angle, that is actually angle PAC. In triangle APC, repeat again, angle MAB in triangle ABM equals to angle PAC in triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually we proved that all the three angles in this triangle ABM are correspondingly equal to all the three angles in this triangle APC. Therefore, those two triangles are similar to each other according to angle similarity rule. So I write it down. The right triangle ABM is similar. This is the sign of similar to the right triangle ACP. According to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB in triangle ABM over side AP in triangle APC is equals to side AM in triangle ABM over side AC in triangle APC. Repeat again, we derive that AB over AP equals to AM over AC. AB is equal to 13 units in its length over AP. AP is the diameter of the circle that is equals to 2R. And it is equals to AM. AM is 12 over AC. AC is 15. We conclude further that 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation and we'll get that 13 times 15 is equals to 12 times 2R. Here we'll divide this equation by 12 and we'll get that 2R equals to 13 times 15 over 12. Here we'll divide this equation by 2 and finally we'll get that R, the radius of the circle that blocks triangle ABC, equals to 13 times 15 over 2 times 12. Okay. Here we will divide both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it will be 13 times 15 over 3 is 5. So in total the numerator will have to only be 13 times 5 over, in the denominator we have 12 times 2 times 12, so it will be 12 times 2 times 12 over 3 is 4. So in total, in the denominator we left only with 2 times 4, that is 8, and 13 times 5, in the numerator is 65. So actually found out that the radius of this circle that blocks triangle ABC, the radius R is equals to 65 over 8 units. Now we can easily find out the area of the circle, because the area of any circle is pi times the radius squared. Okay. So what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down. The area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. So actually the area of the green shape is equals to the area of the circle. The area of the circle is equals to pi r squared minus the area of triangle ABC. What is the area of this triangle ABC? For the drawing it is very easy to see that the area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. Repeat again. The area of this triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h, over 2. The area of the circle is pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared. So pi r squared, it is actually pi times 65 over 8 squared, minus the area of triangle ABC, so it is minus BC is 14 times h, that is 12, over 2. So this expression in total, it is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to 14 over 2 is 7, and 7 times 12 is 84. So it is 84 square units. And therefore, we actually found out that the area of the green shape in total, it is equals to 207.394 minus 84 equals to 123.394 square units. So actually, in both methods, we found out that the area of this green shape, it is equals to 123.394 square units. Okay? So, in the next step, I'll summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the area of this green shape. In the drawing, we have a circle. Inside the circle, we have triangle ABC. Actually, triangle ABC is blocked by this circle. We know that the length of side AB of triangle ABC equals to 13 units, side BC equals to 14 units itself, and side AC equals to 15 units itself. Again, our mission is to find out the area of this green shape. From the drawing, it is very clear that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So in the first method, I presented to you a new rule, and we implemented the new rule in order to find out the area of this triangle ABC. Actually, rule number 4 is a new formula for the area of any triangle. In the drawing, we have triangle ABC that could be any triangle. We know that the length of side AB is A unit, side BC equals to B units in its length, and side AC equals to C units in its length. The semi-perimeter S of this triangle ABC equals to the perimeter over 2. That is to say, S, the semi-perimeter S equals to A plus B plus C, that is the sum of its side lengths, over 2. So S equals to A plus B plus C over 2. And the area of this triangle ABC that could be any triangle is equals to, here the square root brackets is the same for the area of triangle ABC equals to the square root of S times S minus A times S minus B. Again, the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter, that's equal to A plus B plus C over 2, and A, B, and C are the side lengths of this triangle ABC. We actually implemented rule number 4 in our drawing in order to find out the area of this triangle ABC. We defined side AB as A, and we know that A equals to 13. We defined the length of side BC as B, and B equals to 14 according to what is given as the equation. And finally, we defined the length of side AC as C, and we know that C equals to 15. In the next step, again, according to our definition, A equals to 14, B equals to 14, and C equals to 15. In the next step, we found out the semi-perimeter S of this triangle ABC. According to the new formula, the new rule number 4, the semi-perimeter S of our triangle ABC must be equal to A plus B plus C over 2. That is the perimeter over 2. S is A, S is 13, B is 14, and C is 15. According to what is given as the equation, all divided by 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally, in conclusion, found out that the semi-perimeter S of this triangle ABC equals to 21 units. And according to rule number 4, the area of any triangle ABC, it is equals to the square root of S times S minus A times S minus B times S minus C. Okay, so the area of our triangle ABC equals to the square root of S is 21, times S minus A. S minus A is 21 minus 14 times S minus B. S minus B is 21 minus 14 times S minus A. S minus C is 21 minus 15. So, the area is equal to the square root of 21, and 21 minus 14 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. Then we substitute 21 by 3 times 7, and we substitute 8 by 2 times 2 times 2. Here we didn't touch in the number of 7, and we substitute 6 by 3 times 2. Okay. Then we changed the order of the numbers inside the root, and finally we found out that the area of this triangle ABC is equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. We just changed the orders of the numbers inside the root. We didn't change anything else. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and again we have the square root of 2 times 2 is 2. 3 times 7 is 21, 21 times 2 times 2, 21 times 2 is 42, and 42 times 2 is 84. So finally we found out that the area of our triangle ABC is equals to 84 square units. So we found out the area of this triangle. In the next step we have to find out the area of the circle, and then the area of the circle minus the area of triangle ABC is exactly equals to the area of the green shape, that is the area that we are looking for in this question. In order to find out the area of the circle, I presented to you rule number 6 that talks about the radius of a circle that blocks triangle. So here we have, in the drawing of rule number 6, we have a circle. Inside this circle we have triangle ABC that could be any triangle. The length from side AB of triangle ABC is equals to A units, side BC equals to B units in its length, and side AC equals to C units in its length. We define the radius of this circle as R. So according to this rule number 6, the radius of a circle that blocks triangle ABC that could be any triangle, the radius R, it is equals to A times B times C, that is the multiplication of the side lengths of the triangle by each other, over 4 times the area of this triangle, triangle ABC. We can actually implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks triangle ABC. We define the radius of this circle as R, so the radius R, according to the new rule number 6, must be equal to A times B times C, that is the multiplication of the side lengths of the triangle that is blocked by the circle by each other, over 4 times the area of triangle ABC. So the radius R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. We have already found out that the area of this triangle, triangle ABC, according to rule number 4, it is equals to 84 square units. So it is 4 times 84. Then we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. So we left only with 13 times 15. We divided the denominator also by 14. So in the denominator we have 4 times 14, 4 times 84, and 84 over 14 is 6. So in total, in the denominator we left only with 4 times 6. Then we divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So in total, in the numerator we left only with 13 times 5, over 4 times 6 over 3 is 2. So in total, in the denominator we left only with 4 times 2, that is 8. And in the numerator we have 13 times 5, that is 65. So in total, actually found out that the radius of this circle that blocks triangle ABC, the radius R, is equals to 65 over 8 units. What is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle equals to pi r squared. And we have already found out that the area of the circle is equal to 84 square units. Okay. The area of the circle is pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared. So in total, pi r squared equals to pi times 65 over 8 squared, minus the area of the circle, minus the area of triangle ABC, that is 84 square units. This expression in total, it is equal to 207.394 square units. Minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 is equal in total to 123.394 square units. So actually found out that according to the first method, the area of this green shape it is equals to 123.394 square units. We finished with the first method. In the next step I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say from point A, we draw perpendicular on BC. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. Then we define the length of side AM as H. We define the length of side BM as X. What is the length of side CM? From the drawing it is very easy to see that CM equals to CB minus MB. That is to say CM equals to CB, that is 14, minus MB, that is X. So in total CM equals to 14 minus X. Then I copied the right triangle A and B in the new page and we implemented the Pythagoras theorem in this right triangle A and B. So this is the right triangle A and B that I copied from the original drawing. According to the Pythagoras theorem, this right triangle A and B, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 square, that is 169, and it is equals to AM square. AM is 8, therefore AM square is 8 square, plus BM square. BM is X, therefore BM is X square. So I found out that according to equation number 1, 169 equals to H square plus H square plus X square. Here we subtracted X square from this equation number 1, and finally found out that according to equation number 1, H square equals to 169 minus X square. Then I copied the right triangle ACM in a new page and we implemented the Pythagoras theorem in this right triangle ACM. So actually, this is the right triangle AMC that I copied from the original drawing. In this right triangle AMC, AC square equals to AM square plus MC square. Okay, AC is 15, therefore AC square is 15 square, that is 225, plus AM square. AM is 8, therefore AM square is 8 square, plus MC square. MC is 14 minus X, therefore MC square is 14 minus X square. Here we subtract the 14 minus X square from this equation number 2, and finally found out that according to equation number 2, H square equals to 225 minus 14 minus X square. This is according to equation number 2, while according to equation number 1, we have already found out that H square equals to 169 minus X square. So we have two different equations for H square. Therefore, we created equation number 3 that states that H square according to equation number 1 must be equal to H square according to equation number 2. H square according to equation number 1 is 169 minus X square, and it must be equal to H square according to equation number 2, that is actually 225 minus 14 minus X square. So in equation number 3 we have 169 minus X square, that is equals to 225 minus 14 minus X square equals to 14 square, that is 196, plus X square minus 2 times 14x, that is minus 28x. So according to equation number 3, we actually found out that 169 minus X square equals to 225 minus, open the brackets here, we have minus before the brackets, so we'll get there that it will be equal to minus 196 minus X square, and we have minus times minus is plus, so it is plus 28x. So here we have X square minus X square on both sides of the equation, so minus X square we get cancelled, and after we cancelled minus X square, in this side of the equation we left only with 169, in the other side of the equation we left with 29 plus 28x. Here we subtracted 29 from this equation number 3, and finally found out that 169 minus 29 is 140, that is equal to 28x. Here we divided this equation number 3 by 28, and finally found out that x equals to 140 over 28, that is 5. X equals to 5. Well, according to equation number 1, we have already found out that x squared equals to 169 minus x squared. So x squared equals to 169 minus x squared, but x is 5, therefore x squared is 25. So minus x squared is minus 25, and 169 minus 25 is 144. So in conclusion, we found out that according to equation number 1, x squared equals to 144. Here we took the root out of this equation, equation number 1, and finally found out that h equals to the square root of 144, that is 12. Here. H equals to 12 units and x equals to 5. In the next step, we define the center of this circle as O, and we join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle that is equal to R according to our definition. Then we extended the radius AO, that is a straight line, by straight line until it touches the circle. We define the touching point of the extended radius AO and the circle as P. When you extend a straight line by straight line, the result is a straight line. So AP is a straight line that touches the circle at points A and P. Therefore, AP is a chord that passes for point O, that is the center of the circle. And we know that any chord that passes for the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. Here, point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of the circle, that is R. We can see from the drawing that AP, the ref of AP in total, it is R plus 2R. Anyway, AP must be equal to 2R because it must be twice as long as the radius R. So if the radius is R, then AP must be equal to R. Okay, then we join points P and C together by a straight line. By joining points P and C, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Then we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Therefore, this peripheral angle must be equal to 90 degrees. I'll repeat again on rule number 7. We have, according to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing, we have peripheral angle ACB. This peripheral angle ACB rests on AB, that is the diameter of the circle. Therefore, according to this rule number 7, peripheral angle ACB must be equal to 90 degrees. So here we can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP. This peripheral angle ACP rests on chord AP, therefore it must be equal to 90 degrees according to rule number 7. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. In the drawing we have those two peripheral angles. This is peripheral angle ADB. Peripheral angle ADB, it rests on chord AB. We have the other peripheral angle ACB that also rests on the same chord called AB. So because of the fact that those two peripheral angles both rest on the same chord called AB, they must be equal to each other. That is to say, this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle, APC. This peripheral angle APC rests on chord AC. We have another peripheral angle ABC. This peripheral angle ABC rests on the same chord called AC. So because of the fact that those two peripheral angles, they both rest on the same chord called AC, therefore they must be equal to each other. That is to say, if peripheral angle ABC equals to theta, then the other peripheral angle APC must be also equal to theta. Then we focus on the right triangle APC. In the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. It is the sum of the angles in any triangle. Likewise, in the right triangle ABM, This angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we proved that the right triangle, triangle ABM, this right triangle is similar to the right triangle, triangle ABC. This right triangle, triangle ABC. We proved that those two right triangles are similar to each other. Okay, so why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the right triangle, triangle ABM are correspondingly equal to all the three angles in the right triangle, triangle ABC. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AB in triangle AMB over side AEP in triangle APC is equals to side AM in triangle ABM over side AC in triangle APC. I'll repeat again. We will derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, AM is 12, and AC is 15. In conclusion, found out that 13 over 2R equals to 12 over 13 over 2R equals to 12 over 15. Here we cross multiply this equation and found out that 13 times 15 equals to 12 times 2R. Here we divided this equation by 12 and finally found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and finally found out that R, the radius of this circle R, it is equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3, that is 5. So in total the numerator will left only with 13 times 5. Over in the denominator we have 2 times 12. So it will be 2 times 12 over 3 is 4. So in the denominator we left only with 2 times 4, that is 8. In the numerator we have 13 times 5, that is 65. So actually found out that the radius of this circle, the radius R of this circle is equals to 65 over 8 units. And what is the area of the green shape? The area of the green shape equals to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared minus the area of triangle ABC. What is the area of this triangle ABC? From the drawing it is very easy to see that the area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is h over 2. Repeat again, the area of triangle ABC equals to the base that is BC times the height to the base that is h over 2. So the area of the circle is pi r squared, but r equals to 65 over 8, therefore r squared is 65 over 8 squared. So pi r squared in total is equals to pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times h, that is 12 over 2. So this expression in total is equals to 207.394 square units minus the area of triangle ABC, that is actually equals to this expression. Here we have 14 over 2 is 7, and 7 times 12 is 84. So in conclusion, found out that the area of triangle ABC equals in total to 84 square units. And 207.394 minus 84 is equal to 123.394 square units. In conclusion, found out that in both methods, the area of this green shape it is equal to 123.394 square units. Okay, thank you very much.